All right, guys, here we go. Continuing on number 6, 7, and we're also going to do 8 and 9 right now. I just copied the questions and pasted them here for more space for myself to work with. Here's number 6. Make a truth table for this statement P, or if P then Q. This time notice there's only 2 letters, a P and a Q. That means we have 2 to the second power, second from the 2 different letters, equals to 4 different rows for our truth table. So here's our truth table. Did not like my rectangle again. That thinks that it's a circle. Come on. Oh my gosh, I can't draw a rectangle. There we go. Okay, so 4 rows, and it's a pretty short one, I think. So let's make space for the, first of all, the header row. And then we've got 4 additional rows. So 4 rows, not including the header. The header, of course, we've got a P. Then we're going to need a Q. And then what's next in the order of operations? Parentheses come first, right? So I'm going to have if P, then Q. And then I already have a P, so I can put the whole thing together. P or if P, then Q. All right, so just 4 total columns. Just 4 total columns. That's not so bad. Let me just make my table boxes. All right. Okay, and then as far as true and false, we start the same way as always. 2 truths, 2 falses for a 4-row table. And then the second column is going to be alternating true and false. If P, then Q, that's something we did before. Remember, it's false when you start off true on the left and then false on the right. And otherwise, those guys are all true. And now we're focusing in on the P column on the left and the if P, then Q column on the right. Connecting them is the OR statement. So I'm really just doing an OR with the 2 yellow highlighted things I've got there. Remember the trick for OR, look for where they're both false. Actually, they're never both false, right? Here's a true, here's a true, here's a true, here's a true. So the end result is all true. And this is a side note, but anytime you have the last column all true, it has a special name. It's called a tautology. That means no matter what the truth of the individual components of that statement are, the end result is always true. That's called a tautology. Okay, number 7. Make a truth table for that guy. I have this time a P, a Q, and an R. That means I'm going to need 8. 2 to the third is equal to 8 rows, not including the header. This time I accepted my rectangle. So here's my header, and then I'm going to split this into 8 roughly equal parts, roughly equal rows. Of course, they're not exactly equal, but it's okay. Also not exactly straight. I mean, not exactly. My lines are not exactly horizontal, but close enough. Okay, what do I have here? Let's start with the simple statements, the P, the Q, and the R. And then from there, let's build this whole big thing. Okay, what's first in the order of operations? I've got negations, ands and ors, and I've got this conditional statement. Remember, the order is negations first, ands and ors next, and then conditionals, yeah? So negations first, I'm going to need a not P here. I'm going to need a not R. Okay, now let's do the ands and ors. I need a not P and Q. I need a not R or P. So that takes care of the left side, takes care of the right side. All I have to do now is put them all together with one conditional arrow. So that's the whole entire statement. Not P and Q, arrow to not R or P. If it helps to think about it, you see how you have that conditional arrow? That really is the last thing to happen. So if it helps you, you can imagine that there's these invisible parentheses separating the 2 halves or 2 sides of that conditional statement. And then you're basically doing all the other components before you get to that last step where you combine those 2 halves. All right, here, let me just make my lines. Make sure you guys are attempting these before you watch the solutions. Okay, those are all my columns. So what I'm going to do is I'm going to start the usual way. I have 8 rows, which means the very first column here should be half trues. Half of 8 is 4, so 4 trues followed by 4 falses. And this start in itself is a little exercise that you should be able to do. You should be able to reproduce this entire table from scratch. I know on the homework, they kind of a lot of times help you by giving you that first initial part of the table. Oops, sorry. But you should be able to do it without any help at all. Okay, the last of the 3 simple statements, we're just alternating true and false. And then we go into the not P. So not P, I'm focused on the P, and I'm just reversing everything that was originally there. So if you start with P as all trues, 4 trues in a row, that means that the negation is going to start with 4 falses in a row instead. And if you look at the original P, it had 4 falses next. That means the not P is going to have 4 trues next. Okay, next I'm focused in on this R, not R column, which is a negation of the R column. The original R was true, false, true, false, true, false, true, false, which means not R is going to be the other way around. It's going to be false, true, false, true, false, true, false, true. Okay, now so that takes care of the negations. Let's do next the not P and Q. So I'm focused on the not P column here, along with the Q column there. I'm combining these 2 guys with an and statement. Now, you know, it doesn't matter which one's on the left and right in this case, because and statements, you know, they're what we call symmetric. It doesn't matter which is on the left and right, or maybe you call it commutative. It doesn't matter which side it's left or right, you're going to get the same values. So all I'm looking for is, is there a case where they're both true? That's going to make the overall thing true, right? So those are the 2 times it happens. Everything else is going to be false. Remember, ands, right? Ands are only true if they're both true. And that's a fact we just by now should have memorized. If you didn't, then now is a good time to remember that. Okay, now next is the not R or P. So I've got not R or P. Here's the not R column. I'm only looking at this column. And you know, another tip, guys, when you're doing these truth tables, you should only ever be looking at 2 columns max reference to make the next column. So I'm looking at not R and I'm looking at P. I should never have to look at more than 2 at a time. If you are looking at more than 2, that means you are missing a column somewhere. You should make another column. Okay, so not R and P, connecting those is the OR symbol. OR symbol means as long as the one or the other is true, or in other words, if they're both false, that's the one time it's false. That happens right there. And it happens again over here. And it looks like that's the only time. On all other cases, there's at least 1 true, so the rest are true. All right. Okay, last step. Now I have a conditional statement. And now if you look at it, I'm boiling it down to 2 parts, right? The not P and Q, that's this left side. The not R or P, that's this side. And I'm connecting those with a conditional arrow from one to the other. These are orange here. Right? Connecting one to the other with a conditional arrow. So what does the conditional arrow say? Remember, there's only one case where it's false, which is, and let me highlight these things first. So focusing on these 2 guys. So only one case where a conditional statement is false, which is when I start on the left side of the arrow as being true and end up on the right side of the arrow as being false. And it only happens that time. Looking at my columns, that's the only time it happens. So it's going to be the only false. Everything else will be true. All right, so there it is. That's my whole truth table. Okay, 8 and 9 are follow-up questions. Let's erase here my previous highlighting. Try to answer it first before you watch. Okay, number 8 says, if P is true, Q is true, and R is true, then what is the truth value of that big compound statement? And if you look carefully, this big compound statement, that's the one we just did in problem number 7. It's the same compound statement. So the question is, if P is true, Q is true, and R is true, what is the truth value? Well, here's where P is true, Q is true, and R is true, right there in the first column. So if I follow that first column all the way to the end, the truth value of that big compound statement is true, which means my answer is simply true. See, so once I have that truth table, I already have all the individual cases. I can just look up the particular case that I'm interested in. Same thing applies for number 9. If P is false, Q is false, and R is true, let's find that one. Let's do a different color this time. So P is false, Q is false, R is true. That's this one. Right? P is false, Q is false, R is true. So then I look down to the end of my table, and what do I have? I have true again. So in that case, what is the truth value of this overall statement? It's true. I could tell by just referencing the spot in the table. Okay. That didn't take so much time. Let's just go power ahead, and in the same video we're going to finish out the rest of this page of notes. But before we do that, just take a quick break, because we're kind of shifting gears slightly here. Let all that we've learned so far sink into your head before we move on to this last idea. Okay, so take a little pause, take a little 1-minute break here for yourself. And I'm assuming that you've taken that break. Let's get on to the last thing. So last thing, one more thing to learn today, which is given an original conditional statement, we have a few related conditional statements. They have special properties. And these have their own names and are often used in logic, and they're called the converse, the inverse, and the contrapositive. So what are they? Well, first, let's start with the original if P then Q. The converse is what you get if you just reverse the order. Now, some people get hung up on the particular letters. I don't want you to get hung up on the letters. It didn't have to be P and Q. It could have been any other letter. It could have been A, arrow to B. Then the converse would have been B, arrow to A. Or just more generally, think of what's on the left side of your arrow to the right side of the arrow. That's the original statement. Then the converse is what happens if you reverse that and do whatever was on the right side of that original arrow to the left side of that original arrow. Okay, so you're just reversing the order. That's what the converse is. You may have learned this back in your geometry class a while ago. Erase that. So that's the converse. Next is the inverse. Inverse, if you look at it, it's what you get if you keep your original order the same. So P is still on the left, Q is still on the right, but this time you tack on negations to both of them. Okay, and again, don't get hung up on the particular letters. This could have been, if my original statement was if A then B, then the inverse would be not A, arrow to not B. Or more generally, if you're saying there's something on the left of my original arrow to something that's on the right, what is the inverse? It's the negation of whatever is on the left, arrow to negation of whatever is on the right. That's the pattern. Okay, so converse, one thing to do, you just reverse the order. Inverse, you just negate either side and keep the original order intact. Okay, pause for a minute. Make sure you got those two definitions down. That's all these are. They're just definitions so far, converse and inverse. Okay, and then we're going to go on to the last one of these things, which is the contrapositive. I'm actually going to do some color coordinating here. So we'll keep the original statement as yellow. And now here's the contrapositive. Contrapositive, it's kind of like what happens if you take the converse and inverse and do both of them. So if I take the converse, I switch the P and Q's, right? P was originally on the left, Q was originally on the right. Contrapositive makes the Q on the left and the P on the right this time. And then inverse was when I negated sides. And if you look at the contrapositive, both sides are also negated. So what is a contrapositive? One more time. You're basically reversing the order and at the same time negating either side. And that's the compound statement resulting. Okay, so let's, again, the letters are not important. I could have gone A, arrow to B. Then the contrapositive would have been negate the right side, arrow to negate the left side. More generally, whatever you have on the left of the arrow to the right, if that's your original statement, then the contrapositive is negate what's on the opposite side, the right side, arrow to negate of whatever is on the left side. Because that's the pattern. Now I did some color coordinating here for a reason. I have the original and the contrapositive highlighted in yellow right now. And the reason is, let me actually further that color coordination here. The reason for that is those guys are equivalent. The contrapositive turns out to be logically equivalent to the original statement. This is a big deal. This is a very cool fact. The others are not necessarily equivalent to the original, so be careful. But this is a big important fact, because a lot of times in math, what you want to do is you want to prove a statement that's of this form, if P then Q. But sometimes it makes it easier to prove its contrapositive instead, which is an equivalent statement. And vice versa. If you have a statement that looks like this form, I could reverse it back to the original form and prove that instead. And then I've gotten proofs for both at the same time. Now those guys are equivalent to each other, and it turns out if you look at the converse carefully and the inverse, these guys are actually equivalent to each other. And look very closely at it. Actually, the converse and inverse, they're contrapositives of each other. Because look at it. The converse has got something on the left, which happens to be a Q. And then look at what happens when you take the inverse of the original. That's that Q negated on the right side, right? Okay, so let me look at it like this. Watch. Don't worry so much about the letters, but look at what's on the left. Here's the left side. Here's the right side, yeah? So P is on the right. Negation of P is on the left. That's the negation of the right side. And here, negation Q, that's the negation of the left side. Comparing the converse and the inverse. So what does it all mean? It means that the converse and inverse are their own pair. They are logically equivalent to each other. But they are not logically equivalent to the original statement. So the yellows go together as equivalent, the blues go together as equivalent, but the yellow is not equivalent to the blue. The yellow statements are not equivalent to the blue. All right, so finally with those statements in mind, we're just going to go over some quick quick practice. So numbers 10, 11, 12, we're going to write down the converse, inverse, and contrapositives. Start with number 10. So here I've got a very simple one. If Q, then R. So what's the converse? Converse would be what you get if you reverse it, right? Try this out first, guys. So I've got if R, then Q. That's the converse. What about the inverse? Inverse, remember, is what we do if you negate either side but keep the order the same. So it'll be not Q, arrow to not R. And contrapositive is what you do if you get both converse and inverse combined. So you're switching the order and negating. So you're going to get not R, arrow to not Q. All right, that's number 10. Simple as that. Number 11, also easy. Is your if P, then not Q. Converse, start with the right side. Right side happens to have a negation in it already. So when I do the converse, I'm going to write that negation, not Q, arrow to P. All I did was switch the order of what's on the left and right. The inverse, I'm going to take the P and negate it. Take the not Q and negate. What happens if I negate a not Q, though? I get back the original Q. Yeah, I'm assuming you guys try it. Try it first, yeah, before you watch this. And then the contrapositive, I take this original. I'm going to reverse the right-hand side first. That's going to be a Q on the left. And then I'm going to reverse the left-hand side. It's going to give me negation of P. That's it right there. Converse, inverse, contrapositive. And for number 12, if you have onion breath, then you will track dogs. You can jump straight into the answer, but what I might actually recommend to you guys do is do a little translation to symbols first. This part says if you have onion breath. That's like saying if O for onion breath, then, and the if is combined with the then to give this right hand arrow, right? The conditional arrow. You will attract dogs. So the if then together makes the conditional arrow. You will attract dogs. Let's say A for attract. So that's the original, right? So now let's do some translating back to English. Oh, let's write the converse, inverse, contrapositive in symbols first. So converse. I have original statement being if O then A. The converse would be if A then O. Right? Inverse would be, so the original is O to A. It's going to be not O, arrow to not A. And then the contrapositive would be what happens if I do both at the same time, reverse and negate. So reversing the order, I got not A, negating with the A, get not A, arrow to not O. Okay, so now so far I've just converted to symbols, and then I've written the converse, inverse, contrapositive. But the question was given to me in the form of a sentence. And so my final answer should be back in the form of a sentence. So I'm going to translate back to English now. A, arrow to O means if you attract dogs, or you will attract dogs. Then, and by the way, it's a good idea to separate your if-thens halves with this comma as well. If you attract dogs, then you have onion breath. Okay, that's the converse. The inverse is negation of O. So if you do not have onion breath, then you will not attract dogs. And the contrapositive, if you do not attract dogs, do not attract dogs, then you do not have onion breath. Okay, there it is. Now, what I would recommend you guys do is just take your time to think about how this original statement here. Oops. How about how this original if then statement, if you have onion breath, then you attract dogs, how that actually logically, it means the same thing as if you do not attract dogs, then you do not have onion breath. So just take your time to think about how those two things are logically equivalent, and also how those things are not logically equivalent to these things, because sometimes it sounds like it is, but it's really not. It's really not logically equivalent. So just take some time to think about it, and even come up with your own examples of an if-then statement, and think about the converse, inverse, contrapositive. And again, think about how the original conditional statement is equivalent to the contrapositive. Okay, guys, that's it for today. Let's just do a quick recap what we did today. What did we learn about today? Well, we started with just reviewing. We learned how to make a bigger truth tables with 3 things, but using the same operators that we had before, right? The ands and nots. And then we learned about the conditional statement. That was the big new one for today. We learned that it's only false when you start off true on the left and then false on the right. In all other cases, it's true. Then we did some truth tables with that. We practiced just interpreting and translating from symbolic form and vice versa. We evaluated some truth. Evaluated the truth of compound statements involving the conditional statement. And then we learned about the converse, inverse, contrapositive. That's the thing we just did just now. All right, so next time we'll continue on into more stuff like that. All right, guys, have a good day. I will see you next time. I don't know what I'm doing, zooming all around here. Anyways, we're done. Have a good one. Peace.